go. All right, this is Algebra 1 Review for spring 2025. I'm here with Dimitri. Dimitri, say hi to YouTube.
Hello there.
We are doing a review, and we're only going to do the problems Mr. Dimitri wants, which may or may not include stuff from Chapter 5. I know it says a 1. Chapter 8, I know it says a 6. Or Chapter 9, I know it says a 7. Those are our options. Not all of these questions will be on the final, but a lot of them will be. The numbers, of course, will be changed. And, of course, you can use this stuff on your final, so it's pretty useful. So, Dimitri, anything from this guy? Chapter 5.
5.4.3.
Is it a basic or intermediate?
Intermediate, also 5.4.3.
5, 4, 3, and 4, 4. So we're talking word problems. Okay, cool.
Yeah.
So here we go. 5, 4, 3. The sum of Eric and Bob's weights is 9 times the difference of their weights. So if I say E is Eric's weight, so E is going to be Eric's weight, and B is going to be Bob's weight, the sum of their weight is this, E plus B. Are we digging that? Yes? Okay. So, and that is 9 times the difference of their weight. So here's the difference of the weight. By the way, Eric weighs less than Bob. So if I'm going to subtract them, I'm going to do Bob minus Eric so I don't get a negative value for their weight difference. And of course, the sum is bigger than their difference, it says. It's 9 times bigger. So this is not true, right? It's not that if you add them up, you get the same thing as if you minus them. This one's bigger. How much bigger is it than this? 9 times. So if I wanted to make these equal, I would have to times this by 9 or divide that one by 9, right? So that's what's going on there. The positive difference of their weights, so B minus E, right, because we don't want to get a negative answer, is also 408 pounds less than the sum. So B minus E, the difference in their weights, is 408 pounds less than their sum. So this is the sum. And if I want to show 408 pounds less, well, I just take 408 away from this, right? And that's what this will be equal to. So apparently this is the same thing as this, but 408 pounds less. If Eric weighs less than Bob, find Bob's weight. So that's the setup right here. I just got a buzz on my phone. Let me make sure it's not somebody being like, let me in, let me in. Nope, doesn't look like it. But shout out to Abram for emailing me about something. All right, so what we can do is elimination or substitution. And we can figure this stuff out. First, I'm just going to clean up these equations. So E plus B, that's kind of like a standard form, equals 9B minus 9E. And this bottom one I'll get to later. Let's get all my B's and E's together. I'm going to have 10E. And then if I subtract 9B's, I get negative 8B equals 0. So there's a little standard form for that guy. For this guy down here, if I add this E over and subtract B, you might notice the B's go away, right? So I'm going to add this E over, and we're going to get 2 E's. I'll subtract that B. B is gone, and I'll add 408 to the other side. So check it out. We actually get Eric's weight for free from this. So adding E over, 2E, subtracting B gone, move over the 408. E must be 204, so Eric weighs 204 pounds. So that's Eric. But we want to find Bob's weight. Well, if we know Eric's weight, we can get Bob's for free, right? So let's just plug this in. We know Eric is 204, so if we times it by 10, we get 2040. Minus 8B equals 0. So therefore, that must be true. Well, if that's true, that means 8B needs to be negative 2040, right? So B times 8 is going to get us this, right? If they're equal, then we subtract and we get 0. So if we had to guess, how many times do we have to multiply 8 by to get 2040? Well, assuming it comes out nicely, 8 goes into 45 times, right? And then 8 goes into 2,000. How many times? Well, 4 goes into 2,050 or 500 times, right? So here's what I know. 4 times 500 gets me 2,000. 8 times 250 must get us 2,000. Right? So 255 is how much Bob weighs. There we go. Again, using what we know to figure out what we don't know. 5 times 8 gets you 40. And apparently 8 times 250 gets you 2,000. That makes sense, right? Because 4 times 250 gets you 1,000. All right, and then you wanted the green balls, red balls, that one, or what?
Yeah.
Okay, cool. Let's do that. So I'll even color coordinate this for you. Let's make sure it's nice and easy to read. Make this a little bit brighter too. Okay, so we got 5 green balls. So I'm going to say G is the weight of 1 green ball. G equals 1 green ball's weight. And I'm going to say R is equal to 1 red ball's weight. Just so we're clear what's going on here. Okay. And we want to know 15 red and 15 green balls together. How much does that weigh? That's what they want to know, right? They say 5 green balls. So if we take the amount of a green ball's weight and times it by 5, we get the weight of 5 green balls. Is that making sense? 6 red balls. And if we put them together on a scale, apparently what we get is 7 pounds. So we've got some weird weights here. They're definitely not a pound each. They're not even a half pound each or something, right? Something weird's going on. 10 green balls and 3 red balls. Together we're 8 pounds. Interesting. So apparently if we cut the red balls in half, double the green balls, all we gain is a pound. So green balls must not weigh very much, because 5 more of them, we doubled that, and it only went up a pound when we cut this in half, right? So I don't know. We'll have to see what's going on here. If all red balls weigh the same and all green balls weigh the same, what is the weight of 15 red and 15 green together? So don't let me forget, when we find green and red, we're probably going to have to multiply them by 15 and add them up. So let's do this. So what do you think? Elimination, substitution? What?
Elimination.
Elimination, right? So what are you thinking of doing?
Timesing the top equation by 2.
Yeah, so that'll become 10g when we subtract it, and I'll save some space by not doing anything here. I'll just write the times 2. So that's 10 minus 10, which is nothing. We eliminated it. Then we get 12 r's minus 3 r's. That's 9 r's. And then 14 minus 8 is 6. So we now can figure out how much a red ball weighs. What times 9 gets you 6? 6 over 9. So in other words, R, if we factor out a 3 from both of these, it's going to be 2 over 3 after those 3's divide out. So R, a weight of a red ball, is 2/3 of a pound. Okay? So we know R is 2/3. Let's plug that in here and find out what G has to be. Well, if I plug this in here, 3's divide out and I get 2. Right? So that's 2. What plus 2 gets you 8? So I need that to be 6. What times 10 gets you 6? Well, that's easy. 6 over 10, which we can simplify after we factor out a 2 from both. And divide out is 3/5. All right, let's see if...
And then you have to times both by 15.
So what we could do is we could add them both together and then times by 15, but since they don't have commie denomies, I think I'll just times it by 15 individually and then add them up. So times this by 15 and times this by 15, and we'll end up with the weight of each individually, or each individual 15 balls, right? And then we'll add them up. So over here, looks like 3 and 15 divides out to make 5, so that's 10. So that's how much we have of red balls, 10 pounds of red balls. And then over here, these divide out to make 9. So that's how much we have of green balls. So in total, looks like 19 pounds to me. There you go. Janice, yes or no? Or did we do that in class already? Awesome. All right, what else we got from this one? Anything?
That one, yeah.
552.
Yeah.
Okay. The area of a square, they're reminding you, is the square of a length of the side of the square. So that's a lot of squares. But the area is just whatever this is squared. So if we had, let's say, 4 here, then the area would be 4 squared, which is 16, right? That's how area works. Cool. The perimeter, on the other hand, is the sum of all 4 sides. So if it's a square, all 4 sides are equal. The area, in this case, is also 16. 4 plus 4 plus 4 plus 4 is 16. It's not always true that the area and the perimeter are the same, though, right? If I had, it was just a coincidence, yeah. Area is 9 here, right? But the perimeter is actually 12. All right, cool. So that's awesome. So really what we need to start reading is here. The sum of the areas of two squares is 1, 4, 5, while the differences in their areas is 17. Find the sum of their perimeters. All right, so imagine we have a square. And it's x by x. That means the area of this square is x squared, right? And the perimeter is 4x. Are you following me on that?
Yeah.
Right? What if we have another square? This square can be smaller, I don't know. And it's y by y. So that means the area of this one is y squared, and its perimeter is 4y. So apparently we add the areas together, and you get 145. That means x squared plus y squared must equal 145. Okay. And the difference in their areas. So that's x squared minus y squared, assuming x squared is the bigger one. Because we definitely want a positive difference here. Is going to be 17. And what we want to find is the sum of their perimeters. So in other words, we want to find 4x plus 4y. Okay. That's what we want to know. So here we are. Thoughts? You definitely could do that, but there's infinite possibilities here. And there's infinite possibilities there. So finding the two pairs of numbers that work for both is going to be hard to find by guessing. If only we had a technique we could apply here. Elimination or substitution. Let's do elimination. We can actually add these. X squared and x squared makes 2x squared. This goes away, and we get this, which is going to be 163. No, 62. So while this didn't give us an answer right away, it did get us down to one variable, which means we can actually solve now. So think about it. 2 times what gets you 162? What number do you plug in here to get 81?
9.
X must be 9. Now, in order to solve our problem, right, what are their perimeters added together, we need to also figure out what y is. But since we know that x is 9, that's 81. So 81 minus something is 17. How much do you take away from 81 to get 17? What do you add to 17 to get 81? That's another way to think of it. Exactly, because 60 plus 10 will get you 70. And then we need
66.
Close. We're going from 7 to
64.
yeah, exactly. We're going to 7 to 81, right? So we need another 11, so 4. So 64. So that means y squared has to equal 64. What does that mean y has to equal?
Y equals
8. Now, that's not the answer because we want to know what happens over here, right? So 4 times x and 4 times y. So 36 plus 32. Looks like their perimeters, when you add them up, are going to get you 68. Cool. All right. Anything else on this one? Or I think that's all the intermediates because we did one of those in class.
Yeah.
Any advanced questions you want to do? Your call. Some people are like, I'm going to get all the basics and the intermediates, and then I'll go get the advanced questions at the end if I want. It's up to you.
like all the advanced besides 551.
Like, you want to see all of them except 551?
Yeah, because I want to.
Gotcha. All right. Yeah. I did some of these with my other algebra class today, and they're actually not tough, like calculation-wise. It's just you have to understand things, and then the calculation's actually really easy. So I'm gonna do sub for this one. You might think, oh my God, why? Like, how am I gonna get these variables on its own? I'm gonna write something. Let's see if you catch on. Okay, so I'm gonna call that the red equation. I'm gonna call this the blue equation. This is a big brain play. This book showed me this, and I was like, oh my God, that's so smart. 10p minus 91q, and I'm gonna write an equal sign, and I'm not gonna write 1. Instead of 1, I'm gonna write 9p.
The other equation, because they both equal 1.
If they both equal 1, then they equal each other. And that's super useful because look what happens when I move things around to get my q's and p's together. If I subtract 9p, I get p. If I add 92q, I get q. Not equals q. If they both add together and get 0, what must be true about it? They could both be 0, that's possible. But if they're both 0, does that work? Definitely not, right? Here's what this tells us. P is the negative version of q. Right? See how it could be like 5 and minus 5, 6 and minus 6?
Yeah.
0 and negative 0, right, is a possibility as well. So it doesn't tell us what P and Q are, but it tells us that how they're related, right? That's super useful. So watch this. I'm going to go back to this original equation, 10P minus 91Q equals 1. And I'm going to rewrite this. Wherever I see a negative Q, I'm going to replace it with P. You could also replace P with negative Q, but I'm going to replace negative Q with a P. So when I do that, I get 10P. See how this is a negative 91Q? It's the same thing as a positive 91P. Make sense?
So 101P.
What do you times by 101 to get 1? There you go. Fractions division for lazy people. So that's what P is. Now, we could go back and plug this in, but honestly, the easiest place to plug it in is here. If P is 1 over 101, that means Q must be what? What do you add to 1 over 101 to get 0?
Negative 1 over 1.
There it is. It's a clever problem, huh? It's showing that substitution isn't always about switching out variables. Sometimes it's switching out constants. All right, over to here. You want to see this one. I am not going to write anything. You might want to write stuff down, but I'm not going to write anything. I'm going to explain this, okay? It says let A, B, C, D, E be constants in the system of equations. They say B and C are not equal. We know A is equal, right? Because A and A are the same, right? But B and C, they're saying specifically, definitely not the same number, okay? A is not 0, because if A was 0, then this wouldn't even exist, okay? Must the system of equations have exactly one solution? All right, these are standard form, aren't they?
Yeah.
Do they have the same slope?
Yeah.
Do they?
They both have X and Y.
Our delta Y for these is X. Or sorry, A, I should say. Our delta Y is A.
Wait, no, so they wouldn't have the same.
They wouldn't, which means they're not parallel. So they're definitely not parallel, which means we definitely either have infinite solutions or one solution, right? So they're not parallel. That's not a possibility. Are they literally the same equation?
No.
They aren't. So they're definitely not this. So it's definitely not infinite solutions. So what's our only other option?
There's only one solution.
Yeah. They have to intersect at some random point, right? If they're not parallel, and they aren't because their slopes aren't the same, then it's not going to be no solutions. And if they're not the same equation, they told us B and C cannot be equal, right? Then they're not going to be infinite solutions. So they just intersect at some random angle, right? So, yep. Yeah.
It's really simple if you actually understand.
If you understand, it's really easy.
Yeah.
This is math. What we just did, math. No calculation, right? That is math. All right, you said skip that one, go to this one.
Yeah.
All right, I'm going to write this out because oftentimes just organizing your work will let you go, oh, that's how you do that. I'm going to write the first equation like this. And no, the first thing we should not do is try to get rid of the roots. That's usually not the move you want to make when you have problems like this. Because getting rid of them is really messy, and you'll learn that later when we actually try to get rid of roots in Algebra 2. Okay, here's what we have. We want to find R and S, the numbers that make both these true, right? What do you notice? Any strategies that pop out?
Say eliminate it too big.
Currently, when we add them up or minus them, nothing goes away. Good news. To make these match, we have to times the top all by 10, right?
Yeah.
That's not so bad. Number big, but at least it's not hard to work with. So I'm going to do that. I'm going to take that blue equation and times it by 10. So we get 10 times the cube root of R plus 90 times the square root of S equals 570. Yeah, I like how you're like, I see that, but I'm not sure if I want to do that. That's good. I'm cutting to the chase here and being like, nope, that's a good move. But it's good that you were like, yeah, I see that, but I'm not sure I want to, right? Mathematicians definitely need to think, yeah, it might work, but do I really want to go down that path? And in this case, the answer is yes, it's not that bad. So let's make sure I didn't goof. Times everything by 10 in the top equation. Yes, okay, cool. So now we're going to minus them. This is dangerous. A lot of people forget that we're minusing halfway through. This gets eliminated, that's why we did it. 90 root s's minus a negative root s. 91 root s's equals 570 minus 24. So 570 minus 20 is 550 minus 4, 546. Now, assuming this has a nice answer, what times 91 gets you 546? Can you make a guess?
6.
6 is a good guess, right? 5 times 100 gets you 500. But this is a little bit more than 500, and that's a little bit less. So let's try 6. It'll definitely end in a 6 if we times it by 6. 6 times 90 is 540, right? And 6 times 1 is 6. So yeah.
So it means square S.
Uh-huh. Exactly. And we never had to get rid of the root. We just thought, right? Because the root of 36 is 6, and if we times it by 91, you get 546. So now we know what S equals, and you could plug that in, but more importantly, I know the root of S has to equal 6. I think that's actually more important, because whenever I see the root of S, I can replace it with a 6. So check this out. 9 times 6, that's 54, isn't it? What plus 54 gets you 57? What do you cube root to get 3? 27 is correct. The multiplicative third of 27 is 3. 36 rooted is 6. 6 times 9 is 54. That's a 3 all day. That's what works for both of them. It's really not that much further than what we've been doing, right?
Yeah.
It looks super complex, but if you just relax, it's not. All right, this one I know for a fact is unsolvable because I goofed it. I switched the 33 and the z, and I changed numbers up. There's no way to do it. And I'm going to show you why, okay? So this is a magic square, meaning all the rows, all the columns, and these two diagonals, not these mini diagonals, but these two big diagonals, all add up to the same number. What number is that? I don't know. What numbers are W, X, Z, and V, and Y? I don't know. But apparently, we should be able to figure it out from the problem here. Turns out we can't. I'm going to show you why. Here's the strategy. I'm going to write down this row. We know whatever W plus 77 plus V is, it'll equal the exact same thing as W plus 99 plus 44. And yeah, it'll also equal what this is, or this, or that, or that. But I chose these two because look what happens when we try to get our W's together. They go away. And what are we left with?
77 equals 99.
So what does V have to be? 22 would get us to 99, and 44 would get us the whole thing.
66.
V must be 66. So that's the strat. We're going to find two rows, two columns, two diagonals, or one of each, right, that have the same variable and then an extra variable, right? Does that make sense? If we do this again, we can do that with this. So let's do... There is straight down the middle. So that one has X, and this one has X and Y. So let's write that. So 77 plus X plus 33 equals 99 plus X plus Y. So I think just from this logic, you can see what y has to be. Or sorry, yeah, what y has to be.
11.
X really doesn't matter, right? So this already gets us 11 more. So yeah, it's got to be 11, right? If you subtract these guys, gone, gone. There's 99. We're 11 short. So y has to be 11. So I'm going to write that in here. And I think here's where things get dicey. Do you see how W, X, and Z are all in a different column?
Yeah.
Do you see how W, X, and Z are all in different rows?
But they're all in the same diagonal.
They are all in the same diagonal. That's too many variables at once. Because if we set these equal, do you see how they'll both have X, but we'll have W and Z left over? Yeah, I think we'll get stuck. Now let's confirm that. W plus X plus Z equals 66 plus X plus 44. Well, if we subtract X's, we get W plus Z equals 110. But it doesn't tell me what combo of numbers gets me 110. Could be 10 and 100. Could be 55 and 55, right? I don't know. And there's no other pair of numbers that I can set up with equation-wise to make this work.
What if you try to solve for X on its own, maybe?
Now, oh, hi, thank you.
Which one?
Can you get Dimitri a slice of pepperoni pizza?
Yes.
Here, I will give you a plate for him.
Here's your receipt. Here's your jalapeno.
Thank you very much. And then get him. And bring me one of those plates when you're done. And if you guys need plates or napkins or anything, just check the band room.
Okay. Yeah, I know where that is.
We should have stuff. I'm just not 100%.
Do you know where our tables are?
Our tables, we have very few, but they should be over by my desk with the computer.
Oh, okay. Which is very crowded over there.
It is incredibly crowded over there.
So we'll just grab one from under the sink. I'm gonna go to the back room.
I will join you guys after I'm done with Dimitri.
One or two.
Give him two. Get two pieces.
Yeah.
Here you go. Thank you. Yep.
There, we might have leftovers.
Yes, I figured you would. All right, cool. So yeah, trying to get X on its own.
You're not live, are you?
Yeah.
Yeah, we are.
Oh.
And I mean, it's not live, but it is recorded. Yes.
Oh, okay. Okay. Bye.
Say hi to
Bye
YouTube.
YouTube. Bye YouTube.
Yep. There you go. All right. So yeah, we're never gonna get a situation where we have X in both equations, but not extra variables in the others, right? So if we chose this one, yeah, there's just one X, but what other one has X in another variable? None of them, right? The only thing we have is diagonal, so it's stuck. If these were flopped, we'd be okay, because then X and Z would be in the same one, and then we could choose one without Z, and we'd be fine, right? So, oops.
Yeah, so we actually messed it up.
Yep, sorry. This one back here, I'm not concerned about. If you can't figure that out on your own, we're just going to leave it alone. It takes a really long time.
I just didn't notice that.
Yeah, it takes a really long time. I'm not worried about it.
Okay, yeah.
All right, let's move on to the next one. Anything from 6 or chapter 8, as it were.
I'm fine with like
I figured. Intermediates.
A24 maybe. Intermediate.
Yeah. Okay. Okay. So without finding 2 points in the line and calculating slope, which will take forever, can you just tell what's going on here? Well, this right here looks like it's going at a 45-degree angle, which means that slope is probably equal to 1. So we're going to say that's equal to 1. Now, is it actually, maybe that line's slightly askew? I don't know. But it looks pretty close to be equal to 1, right? 1 over 1, 2 over 2, 3 over 3, all 45-degree angles. It's definitely positive. So there you go. This one, it's hard to tell which one's line and which one isn't. But it's either this or it's that. It's probably the bold. But either way, they're going to have the same slope, right? It doesn't matter which one you think the line is. That slope is equal to 0. Cool. Again, this one, which one's the line? Well, they're both going to have the same slope. The slope is undefined, right? Because it's going to be infinite verticality. So delta y could literally be anything. And delta x would be 0, not changing in the horizontal direction. That's undefined. So 5 over 0 would be an example. 6 over 0, but it's undefined. This one looks pretty 45-degree to me, so that's definitely equal to 1. Honestly, I think if we go back to this one, it's actually going to be a little bit more than 1, but I don't care. All right, this. Definitely not a 45-degree angle. It's pretty steep, and it's negative, right? So this is negative, and it's a pretty big negative number, right? So like -6 or something, right? This could be it. Every time we go 1 to the right, we go 6 down or something. That's going to make it pretty steep. So if the slope is equal to -6 or something, right? Is that greater than or less than -1? That's less than -1. Nice job. A lot of people goof that up, right? So it's definitely less than -1. Speaking of steep, this looks like we're going over like 1 to the right, not even, and going like a bajillion up. So that's a really big number, right? Delta y is really high, delta x is really low, so definitely greater than 1. How you feel?
Good.
Mm-hmm. Anything else you want to see?
Entry 1.
Mm-hmm. This one?
Yeah.
All right. So we've got 3 different points. The x values of both of these are kind of gross, but whatever. They're just points. And they're all on the same line. So what does that mean if they're all on the same line?
They're the same.
Ding, 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 ding. So the slope between these two, we'll call it M1, will be the same slope between these two, M2. Or we could pick these two. The reason I'm picking this one both times is because it doesn't have a variable, right? It's going to be easier to work with. So I know those slopes are identical. So that means delta y and delta x for both is the same. So let's write that out. Let's write that equation. Delta y of delta x of one equals delta y of delta x of the other. So here, if I do 3 minus 5, that's the delta y for these guys, right? And the delta x is 2 minus the quantity of a minus 7. And you do have to put that in parentheses. We're subtracting all of that, right? And that's going to equal the delta y and delta x of these two. So again, delta y is 3 minus, looks like -1. 3 minus -1.
Plus 1.
Or just plus 1. And delta x is 2 minus the quantity of 2a plus 4. So we're going to simplify this down, yada, 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 and then we'll be able to solve for a. Let's do that. Looks like -2 over minusing a -7 is really adding it. So it's going to be 9 minus a. Over here we get 4. 2 minus 4 is -2. So I'm going to write -2 minus 2a. That's a -2 minus 2a. It was gross looking. -2 minus 2a. There we go. So why is this a hard problem to solve for a? What makes it tough?
A common denominator.
They don't, and it's that they have denominators at all, right? So let's get rid of fractions. I'm going to multiply by 9 minus a to both sides. To every term, right? That's all one term, that's all one term. These divide out, that's why I did it. And what we end up with is -2 equals 4 times 9 minus a over -2 minus 2a. You could distribute that if you want. We probably will eventually. Oh man, I sure wish this problem didn't have fractions.
And then times the other by that.
Mm-hmm. These divide out. That's why we did it. And what we end up with is -2 times all this. I'm going to distribute now. 4 plus 4a equals 36 minus 4a.
I could probably.
Yep, I figured. Solve from here, get a.
Yeah.
833. Bailey Kibido, if you made this pizza, it is incredible. Very well done.
Uh, 3B.
Yep. Finding the midpoint's easy.
Yeah, midpoint's easy.
Let's do that. Average of the x's, average of the y's.
Yeah.
So here's P. Here's Q. And Q is 5, negative 2. And P is negative 3, 2. And the midpoint of that is the average of the x's, average of the y's. So if we average these, that's going to be 2 divided by 2. 1. If we average those, 0 divided by 2. Try it again.
Oh.
Add them up, divide by 2. Yep, we get 0 divided by 2, which is 0. There's the midpoint. And then we said, find a point T such that Q is the midpoint. So basically, T is some point over here. That makes Q the midpoint. Okay. So apparently, we average these together and we get 5. That means these have to add to 10, don't they? 13.
Yeah.
See my logic? Apparently we average them when we get negative 2. So these need to average when we add them together. When we add them together, they got to get negative 4. Gotta be. Negative 6 plus 2 is negative 4. Divide by 2, we get this. Ta-da. How's that? What do you think about 843? Okay. Eight, 5, 3. Okay, so we want a line that goes through 0, 5. So when we plug in 0, 5, it works in the equation.
Yeah.
And has slope negative m, where m is this guy's slope. What form is this in?
Standard.
Ax plus by equals c? No way. But it is the one that you like from 8th grade probably, or 7th grade. That's very funny. We don't use it a ton in my class because it's just not as useful as standard form. But this is y equals mx plus b, where m is the slope and b is the y-intercept. It's slope-intercept form. So this literally gives us the slope for free. It's 3. So the slope of this guy is 3. The one we want is going to have the negative version of that slope. So our slope is negative 3. Okay, cool. So if you want, our equation is going to look like this. Yeah? If you want to use the same form. You could obviously use standard form. It doesn't really matter. If you use standard form, you would have gotten this. Negative 3. What am I doing here? Delta y, 3x. How did I goof this? Did I goof this? Negative slope. This is the slope. Oh, I know why. I'm writing standard form weird. X before y.
Yeah.
All right. So delta x in this case would be 1, and then y would be plus 3. And then we would get, nope, I goofed that. 3, and then 1. I'm having a aneurysm right now. Does that make sense? Right. Change one of the signs. That's delta y. That's delta x. Cool, and then you would plug in 0, 5 and see what you get, right? Plugging in 0, 5 is pretty easy here. You get 5 for C, right?
Yeah.
But it's also pretty easy here, because if you plug in 0, everything goes away except B. So if this has to be 5 and this is 0, B has to be 5. So either of these work for me. And like I said, B is the y-intercept, and that's exactly what this is, right? 0, 5. So yeah, that one's kind of easy to work with if you know what you're doing. If not, use standard form. Who cares? Just try not to lose your brain like I did. All right. 855. Yes, no, maybe so. What do you think?
think so sure.
I figured you would, because you don't like y equals mx plus b form. Check this out. We know if we get in this form, that's the slope, right? So let's convert this to that, and we'll prove that that's what happens for m. So here's what we're going to do. ax plus by equals c. How do I get it in this form? I get y on its own, right? Y in terms of x. So I'm going to do that. And I'll do it slowly. See how I got there? Subtract ax.
Yeah.
I wrote ax first because this one has the x part first. Then I'll divide everything by b. That's a c.
Wait, how'd you
Yep, there we go. So guess what the slope is? Negative a over b. And the y-intercept is c over b. That's kind of fun. Every time, no matter what the numbers are. So there's your proof.
Interesting.
Yeah, right? So technically, there's a y-intercept formula. From standard form, you just take c and divide it by b. Guess what the x-intercept form is? C and divided by a. Turn to bed. Go ahead and read these. Tell me what you think.
Yes.
Every line has both an x-intercept and a y-intercept?
Yeah, sometimes it just takes a very long time. Well, actually, not every line.
Only has y-intercept.
Yeah.
Mhm.
No.
But they gotta have at least one.
Yeah, they have to at least have one.
Yep. Do they have to be different points if it has both, though?
Yeah. Well, actually, no. 0, 0.
That's an x-intercept and a y-intercept. Nice job. Yep.
Okay.
Oh, yeah, we definitely want to see 8, 6, 1, I bet.
Yeah, just reading that.
So we have a line that's perpendicular to this guy. If they're perpendicular, that means they hit at 90 degrees, right?
Yeah.
So that means if one of the slopes is like 3 to the right and 2 up,
There has to be.
the exact opposite, right? It's going to end up being, if it hits at 90 degrees, the slope for this guy is going to be 3 down and 2 to the right. Okay? I drew that really poorly, but you get the idea, right? The exact opposite. We call them opposite reciprocals. So the slope of our line is perpendicular to this guy's slope. So what's this guy's slope? Delta y is 4. Delta x after you change its sign is 3.
4 over 3.
So our line slope, the slope of line L, is going to be negative 3 over 4. Remember, one's going up, one's going down? So not only are they reciprocals, but they're also negated, right? If one was going up before, it's got to go down this way, right? If they're both heading in the same general direction, they're not ever going to be perpendicular. Cool. And it has the same x-intercept as well. So the x-intercept of this guy, x-int. Well, an x-intercept is where it hits the x-axis, right? What do all the points on the x-axis have in common?
Go for y.
Yep, no height, right? They're all sitting flat. So if we know y has to be 0, what does x have to be? What's up? Say hi to YouTube. We're not live, but we're recording it for people to watch later. Yeah, jalapenos, sorry. It's probably stinking up the whole hallway.
Oh,
Anything I can do for you?
no, I'm just here for movie night, but I want to know if I know math.
Oh boy. These are spicy questions, so this might be a little, might be a little intense. If I wasn't a math teacher, I would know this.
It's perpendicular. I know what that means.
Yeah.
To the graph of
Words.
4x minus 3y equals. Okay.
Yep. Yeah. Yep.
I could do it if you gave me a refresher.
Oh, absolutely. Yeah, you're a
on,
smart
like,
person.
slopes and stuff,
You can
right?
figure things out, absolutely.
Yeah.
And that's the real ability we want to teach them, right? How to figure out things you don't know based on what you do know.
That's exactly true. Yeah. And remembering what perpendicular means.
That's important.
Is key as an adult.
I call that that type of knowledge that my grandpa's name is Herb. Like, if I tell you my grandpa's name is Herb,
Yeah.
Are you smarter now? Probably not, right? Especially since you don't even know if his
But
name's
in
really
future
Herb.
conversations, you will have a leg up.
That's true, unless I lied to you. You have no way to verify this. So it's just kind of made up
That's
knowledge.
true.
Why do we have it? So we have a way to communicate with each other. But it's not necessarily true 100% of the time. And I will never reveal whether my grandpa's name is really Herb or not. Sorry.
It's
But
not, because you pronounce it herb.
oh, you think so? Yeah. Bye. I'll see you soon, hopefully.
Okay.
All right. That was special guest star, Betsy Coy. So we want to find standard form of the equation. We know its slope is this. So that means delta y is -3. And delta x is this. Got to change one of the signs, right? I made it double negative. Do you want to make them both double positive? There we go. Both double positive. When you have a choice, stay positive, right? We know it shares an x-intercept with this. It shares this point, right? So that means this point doesn't just work on this equation. It works on ours. So we get -6 plus nothing is c. C is -6. Yep, C is -6.
Would you be alright if I grabbed one of our coolers and made lemonade?
Yeah, it's cool. I don't
Okay.
care. Just clean it when you're
I
done.
didn't want to grab it and then.
Yeah, just clean it when you're done.
Alright.
All right. Find an equation whose graph is a line passing through -1, 4, and is parallel to this guy. So first off, is this standard form? Look closely. Nope, but we can make it standard form. X minus 3y equals 6. Now it's standard form. If we want a line that's parallel to this, it's going to have the same slope, right? So this guy's slope is 1/3. So guess what our slope is for other line? Yeah, slope of our line is 1/3. So we know it's literally going to look the same way. That's easy. And apparently -1, 4 works on our line. -1, -12. Did it? Hooray for parallel lines. Same slope. Super easy. Solves half the problem for you. All right, turning the page. We're on to advanced questions. You want to do advanced stuff or you want to move on to the next one?
Advanced.
Oh boy. When finding the formula for the distance between these points, we assume that B was above and to the right of A, right? X2 and Y2 being bigger numbers than X1 and Y1, right? Yeah. Makes it easy when you subtract them. X2 minus X1, Y2 minus Y1, right? We get positive answers. Does the same argument work when A and B are not in this position relative to each other? And the answer is yes, because you know distance formula. X2 minus X1 quantity squared plus y2 minus y1 quantity squared. And we write y2 and x2 first because, in theory, y2 and x2 are bigger, right? But what are we going to do to them? We're going to square them. We're just going to make everything positive, so it doesn't matter anyway. Oh my god, no, this one's small, so we get a negative answer. We're going to square it. Distance doesn't care about direction. All right. Yeah, right? Yeah, it squares it. And then rooting it afterwards, basically, I mean, we're going to add them first, but then we root it, right? It's basically undoes all that. All right, cool. Let point A be 1, 7 and point B be -6, -3. What point is on the segment connecting A and B such that the distance between from the point to B is 4 times the distance? Oh my god. So what we're doing is we're not finding midpoint. We're finding like a 1/5 point. So let's draw this out. A is here, 1, 7. And B is over here at -6, -3. Definitely not drawn to scale. This is definitely below it on the left, and this is above it on the right if you use a coordinate plane. But who cares? It's just a drawing. What point is on the segment connecting A and B such that the distance from the point, so I'm going to put another point here, such that the distance from it to B is 4 times that of A. So in other words, I need a point here. See how this point right here, I'll call it C, is 4 times away from B than it is from A? Cool. So we're not finding the midpoint. We're finding something that's 4 away versus 1. We're finding the 1/5 point, okay? So how do we do that? Well, check this out. I know the slope between A and B. If I look here, the distance between there is 7, but it's going down, so -7 for delta x. And if I do delta y, 7 going to -3 is also going down. It's going down 10. So my slope is 10 over 7. That's my slope. So if I were to draw this out a little bit better, here's A, here's B. 10 to the right and 7 up is what we're doing, right?
Yeah.
I want to find a point that's here. So I break this up into smaller triangles. This is actually some really not nice numbers. I probably made these not very nice on accident. If I were to go, let's break this up into, we said 4 and 1. So here's this, 1, 2, 3, 4, and 1. Okay, does that make sense? Yeah. Okay. If I was to break this up into little triangles, okay, and each of them were equal. 1, 2, 3, 4, 5 segments down here, right? So each of them are 2. You feeling that?
Yeah.
Okay. And here we have, and I'll do it in green or something. One, 2, 3, 4, 5 segments there. 7/5 for each of those. So to find C, we need to add 7/5 to the y value. 1, 2, 3, 4 times from B. And we're going to add 2 to the x value of B. 1, 2, 3, 4 times. So basically, what I'm arguing is we're going to take B, which is -6, -3. And what we're going to do to the x value is add 2 4 times, otherwise known as adding 8, right? We're going to add 8 to this. And unfortunately, because I didn't choose good numbers here, we're going to add 7/5, 1, 2, 3, 4 times. So I'm going to add 7/5 times 4, which is 28/5 to this guy, to the y value. And that's going to get us the point that is almost A, but not quite. That's going to get us 2. And there are 15/5 here. So if I take this away, I end up with 13/5. That's where C is. Gross. Gross, disgusting, but it works. Sorry that we got 7/5 over here. I did it good with the 10.
Thankfully.
Yeah, I needed to pick a number divisible by 5 for the slope at the bottom. So if that was 15, chef's kiss, right? But it's 7. All right. Prove that the midpoint of the segment with endpoints having coordinates x1 and x1, y1, and x2, y2 is this. So in other words, prove the midpoint formula. All right. What must be true if I have 2 points and I say this is the midpoint? How do you know something is the midpoint? It has to, 1, be what?
The average of the points.
Yeah, in the middle. It has to be the average location, right? It has to be in the middle. Here's the problem. Here's the problem. Here's the problem. Here's A. Here's B. And by your definition, that could be the midpoint because it is the same distance from both. It has to be in the same line. So we need 2 things. 1, it has to be in the middle. 2, same line. So those are the 2 things we need to prove that this always gives us the midpoint. So, how do we prove something is in the middle? Pretty easy. If it's in the middle, it's going to be the average location, etc. We know that it's going to be between these 2. So, in other words, if I find the distance between A and the distance between, well, I should say, the distance between A and B, right? If I find the distance, let's say the distance is 5. If I divide that in half and add it onto A, I'll get the middle, right? So let's prove that this works that way. So let's find the distance between A and B. Well, how far are they apart horizontally? x1 minus x2. How far apart are they vertically? y1 minus y2, or, subtract them whatever order. And then root them. We're going to take half that distance. Oh God, we're going to take half that distance, and we're going to add it on to the original coordinate. So in other words, we're going to do this. Okay, this looks really complex, but it's not. Okay, do you see I have all these different variables? Really complex, right? Isn't half the horizontal distance this? Right?
Yeah.
And then we're going to add it on to the original x value. Yes? We can avoid having to deal with all this nonsense if we just focus on the horizontal part first and the vertical part later. I'm going to get commie denomies over here. Oh, and we need this to be positive. That's a 2, that's a 1, that's a 2, that's a 1, plus x1. There we go. So I get commie denomies, 2 over 2. You with me on that? What's 2 x1s minus an x1? Yep, so we get x2 plus x1 all over 2, right? See how we get that 1x1 there? Positive. And we add on the x2. We get commie denomies. Oh my god! That's the middle, isn't it? Oh wait, you can't see. Right? Literally what we got when we took half the distance and added it onto the original. Guess what'll happen when we do with the y's? Yep, so I'm going to save time. Okay? So we proved that it's in the middle, right? Like equal distance between A and B, right? When we find the middle by adding half onto the original, right? Adding half the distance onto the original, we get this. Cool. Okay. How do we prove that these points are on the same line? How do you prove 2 points are on the same line? They'll have the same slope. So, is the slope between here the same as the slope between here? We're going to find out. We're going to find out. What's the slope between A and B? Well, our slope is y2 minus y1 over x2 minus x1. That's the slope between A and B. Is it equal to the slope between, I don't know, A and the midpoint? Well, what's the slope between A and the midpoint? It's going to be y1 minus y1 plus y2 all over 2. Because that's the y coordinate of our midpoint. It's gross, but that's the y value of our midpoint. And, of course, between this one and that, x1 minus our x value for our midpoint, which is all this junk. So are these equal? That's the question. Imagine I get commie denomies. 2 y1s over 2. 2 y1s minus 1 y1 is 1 y1. So I got commie denomies, 2 over 2. You seeing this? 2 of them minus 1 of them is 1 of them, plus another one, commie denomies. Guess what'll happen down here? Same thing. Is this the same as this? Did I goof somewhere? I think I might have subtracted the big from the small. Here, let's put a 2 here. My bad. 2 y2s, 2 x2s, 2 y2s minus 1 of them. y2, yeah, oh, I missed a minus sign. That's what it was. My bad, my bad. So it doesn't matter if it was y2, x2. 2 y2s minus a y2 is 1 y2. We cool with that? And then we have minus a y1. I missed that double minus, right? Minus this guy and minus that guy. So we get that over 2 over x2 minus x1 all over 2. Is this exactly the same? And the answer is yes. Think about it. If I have a number, let's say 8, and I have it over 4, is that the same thing as 4 over 2?
Yeah.
This is a number, and that's half of it. This is a number, and that's half of it. It's proportional. So yes, we've proven that this is on the line with these two, right? It has the same slope. Ugh, what a nightmare. Much easier to just take it for granted. All right, then we've got all this. I'm not too worried about that. It's going to take a long time. That last one was a long time too. Then we got medians and stuff. This is trying to connect to geometry. I'm not too worried about it either. You'll learn about it last year. These guys are both, or you'll learn about it next year. These guys are both on the same line, which means they must at the same slope. So you can figure that one out, right?
A equals 2.
So we know, well, hold on, not necessarily. 2 over B is the slope of this one, right? A over negative 3, because you got to change one of the signs. The slope between this one. And if they are both the same line, then their slopes should be equal, right? So these two things should be equal. What numbers do I plug in for A and B to make that happen? Another way that you could try and solve this is a system of equations, right? X and Y aren't super important. It's the A and B that you want to worry about. I'll just leave that for you to think about, because if you can't, you don't need to be doing it anyway. Graph lines for K. Yeah, we graph a bunch of them because K changes. How can you quickly use this to produce another one? Well, they have the same slope. It's just the location's different. But I'm not super worried about that. Find A and B if they pass through this and it's parallel to this. So yeah, another one where it's like, oh my god, right? It's parallel to this guy, so they're gonna have the same slope, right? And it goes through 2, 5. So you know that 3, 5 is gonna be equal to A over 2. Does that make sense? So like the slope of this one is negative 3 over 5. And that should be the same thing as this guy since they're parallel, negative A over 2.
I'm not gonna explain it, but that's like after. So that would then go
Yeah.
negative 6. So A would be 6.
So here's what I'm going to do. I'm going to times this by 2 over 2 to unsimplify it. You know what I mean?
Yeah.
And I'm going to times this by 5 over 5. And now we have common denominators. So we get negative 5A. So A has to be 5/6. 6/5. That's kind of gross. But it's 6/5. There's probably a better common denominator that doesn't get fractions like this, but like that's what A would have to be. So A is 6/5, and then from there we can move things around and figure things out. If A is 6/5, I'll just keep going, I guess. And this equals B. We know that 2, 5 works in it, right? So if I plug in 2, 5, I get 12/5 plus 10 equals B. So that means my equation is 6/5 x plus 2y equals 50/5 plus 12/5 is 62/5. If you don't like fractions there, you can multiply to get rid of them, and you can write your equation as 6x plus 10y equals 62. Did I do that right? Times by 5, 10, 5. Yeah, there we go. And you could even simplify that further because all are divisible by 2. But that's the idea. Mary uses a secret code to write messages. Ooh, this is interesting. Mr. Morrison said he was helping somebody with this, and he was trying to find a different way to do it because he kept finding Mary's number. It's been a long time since I've done this one. Do you want to try it, or do you want to move on to something else? Up to you.
I'll just move
Okay. All right. I know. I'm trying to save your time. All right. Last one, your call.
maybe. Just because
Basic.
Intermediate.
Yeah, I get you. 952. I haven't converted all my tests to the spicy scale yet. Oh, God.
Yeah.
This one looks awful. I don't even know if I've done this one before because we haven't made it this far in the book yet, other than this year. Let me think about it. So A, B, C, and D are positive. Cool. D's the biggest. You get the idea. Which of the following is the biggest? All right. So 2 small numbers over the 2 largest numbers. No. No. Small and big over the medium ones. B plus C, the medium ones, over these guys. Maybe. B plus D, A plus C. Or C plus D over A plus B. Well, wouldn't the biggest over the smallest be the biggest? You know what I mean? Big number over small number. Ta-da.
Yeah.
That's my logic. Moving on. I think that's right. I can check. 952. Let's see. I literally can't change the problem for this because it's all variables, so let me just see.
Yeah.
952. That's my logic. There might be something smarter here. I learn things from this book all the time.
I mean, you could just plug in random numbers for it.
C plus D over A plus B because... well, right. But depending on the numbers you choose, that could change things. But I think this one will always be the biggest regardless of what numbers you choose. So it says this one is the biggest because it has both the largest numerator and the smallest denominator. So yeah, that's exactly what we said. Cool. All right. Yeah, makes sense to me. The rest of them are just kind of smoke screen. Find the maximum and minimum values of this. So we're trying to make this maxed and this minned. So we're going to get two different answers here. If y is between -2 and 2, inclusive, y is less than or equal to this, and it's less than or equal to that. Yes? All right. Well, my thought is let's make a graph. Although, hear me out. Yeah, we'll just make a graph. I wanted to show you, like, just imagine the graph in your head. Here's what it's going to look like. Here's what we really need to know. But I'll just draw it for you. Okay? So here we go. When will this equal y? It's in slope-intercept form. Do you see this? So we know our y-intercept's at 5. And our slope is -3. So here's our y-intercept, right? Plug in 0, you get 5, right? And slope is -3, so if I go down 3 and write 1, I get another point. So here's this guy, and it could be equal to it. So I'm going to use a solid line. Pick a point to test. How about 0, 0? 0 plus 5 is greater than 0? Yeah, that's true. So we're definitely going to shade this side. So I'm going to do this kind of lightly. That's this guy. Okay, that's purple. Let's do green. Oh my god, it's the same thing except it doesn't have a slope of -3. It does have the same y-intercept though, right? Make sense? Plug in 0, you get 5. But now we're going to go up 3, right 1. So 1, 2, 3, and right 1. There's that. And here's this guy, which it could be equal to. If we try 0, 0, is 0 less than or equal to 5? Yes. So we're going to shade the side with 0. Notice this is the area they both share, right? So anything in here or on these lines should work for both, okay? However, we also know that this is true. Y has to be between -2 and 2. So I don't know where that is off the top of my head, but I could figure it out, I suppose. But it's going to limit us between... oh, I do know where it is. Yeah, I do know it because it's y, not x. So it's between here and here. You see how all these are y values between them?
Yeah.
+2 and -2. So here's where things get interesting. This point, this point, this point, and this point are on the boundary of the shared area. That's the only place where pink, purple, and green all live. It is. So what do we need to know? We need to know what those coordinates are, right? So I need to know where the purple intersects the pink, right? Pink number 1, I suppose. Here, I'll use this color for down here. That's also looking pretty pink, isn't it? Maybe I'll use black. This guy is black. Okay. So where purple and pink intersect, I need that. Where green and pink intersect, I need that. Where black and green intersect, I need that. When black and purple intersect, I need that. Now, luckily, this is pretty easy. Where do purple and pink agree? Well, pink says y has to be 2. So if y is 2, what's the dot here? Let's figure that out. If y is 2, and basically we're just wanting to know where it's equal, right? It's on the line, so I'm just going to put an equal sign. What does x have to be? Well, notice 5 plus what gets you 2? Try again.
Oh, -3.
So x has to be 1. So this coordinate is 1, 2. Now where is green going to have y equals 2? Well, You're never going to believe this.
Opposite.
It's -1, isn't it? So we have -1 comma 2. These are all points that could min or max this value, right? These are all the critical points. Let's grab this guy down here. This is where purple and black intersect. So that's when y is -2. So if I do that, we get this, -2. What plus 5 gets you -2? -7, right? So how do I make that -7? 7/3, right? So this guy is 7/3 for x and -2 for y. Okay, that's kind of gross. Oh wait, hold on, I wrote it in the wrong spot. It's over here, 7/3 -2. The last one I need is, where does black and green intersect? Well, that's where green equals -2. So -7, x is -7/3, right? So this one's going to be -7/3, comma, -2. So which one of these, when we plug it in, will make this as big as possible? Well, we want x and y to be big numbers, right? But we've got some negatives to worry about here, here, and here. So those probably aren't ideal. 1 and 2 might be the best. 4 plus 2 is 6.
Yeah.
This will get me -4 and 2. This will get me a fraction and then we'll negate it. This will give me a fraction, we'll make it even more negative. That's the worst, right? So definitely 1, 2 is the max. Which one do you think is going to make this as small as possible?
The double negative.
Ding, 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 ding. Min. Yay, optimization. Like calculus, but early, essentially. And we didn't do optimization until calculus. Oh, wait. Now we're on spicy. Let me know what you want. Or we can be done, or whatever you want to do. I don't care. It's your show.
I think that's good.
Say again?
I think it's good.
Awesome. All right. That's it. Bye, YouTube. I'll be praying for all of you on your finals. It won't matter because God does not listen.